Welcome to another lecture. Today's topic is binary coded decimal and EXCESS3 code. Coming to the BCD, the BCD is represented by 4 bits. 4 bits, and we can only use values from 0 to 9. These are the numbers 0 to 9, and we are going to convert to the EXCESS3 code. What is EXCESS3 code? EXCESS3 code is just an addition of 3 to the number. For example, 0 will be 0 plus 3, it will be 3, and 1 plus 3, that will be 4, and this will be 5. If you convert it to the binary form and go to the last, here you can see 6, 7, 8, 9, 10, 11, 12. This will be 12, this will be 11, and so on. This is another table, and as I have shown, this will be 3, 4, 5, 11, 12. You can simply add in the binary form by taking uh, the binary number. Let's take a 000 for start, and we have to add number 3. So number 3 is represented by 0011, and if we add, we get 1, 1, 0, and 0, and this is the number 3. Similarly, if you do for 001, 1 will be 0, and 1 will be carried here. Then again 1 will be 0, 1 will be carried here. So this will be 1. I mean, this will be 0, 1, 0, and 0. This is 4. This is exactly we have mentioned. And you can do binary addition, or you can simply add in the decimal form and convert it to the binary form. Next is conversion from binary to gray code. This is a list of binary numbers, and you all know what these numbers are. This is 0, 1, 2, and so on till we have taken till this will be 8, this will be 9, from 0 to 9. Now, how to convert it to gray code? So, there is just small method. We have to use XOR operation, and we're going to discuss by taking it one example. Let's take example again as 00. And we have to use XOR operation. Now take the leftmost significant digit below, write, write down as it is 0. Now take the first two pair from the upside and do XOR operation. We get 0 because whenever there are two similar bits, the XOR operation will give the result 0. And whenever there are different, it will give us 1. In this case, we have only similar value, and this will be 0. Take the next pair, this will be 0. And next, let's take another example. In the case of 1, let's take 2. Yeah, 0 0 1 0. Now take the leftmost significant digit as it is. Now take the first two pair from upside, do XOR operation, this will be 0. And take the next two digit, here is 0 and 1. These two bits are different, and we get 1. Again take the next two pairs, 1 and 0, and these two bits are different, so we'll taking 1. So this will give an XOR operation of 3, but we won't be calling it as 3 or any other number for other conversions, because in gray code we will be only representing in binary form. We won't be converting it to any digit. The conversion from binary to gray code in the form of 0 and 1 will be the final one. We won't be using it to convert the gray form to any other decimal or octal form. And now other questions come, like how to convert from gray code to binary. So let's get into it. See, this is a gray. Let's take one example. Let's take 1100. Okay. Now we have to convert it to the binary form. Take that 1100. Now, as usual, take the leftmost significant digit, write it down below 1. But here, the pairs we have been taking from left to right on the top in binary to gray code conversion. But in gray code, we have to take from bottom to up. Like the for one, we have taken, we note it down at the one at the below. So next we have to compare this one with this one. So 1 1 XOR operation will be 0 because the bits are same. Now we have to we have to compare the next two bits, bottom to up. Next 0 0 will be again 0, and this 0 and the upmost 0 will be again 0. So if you see in the table, we get the answer 100 successfully. And we represent binary as 2 base, and represent gray as G. With this, we complete the video from conversion of binary to gray code and gray code to binary. And if you like the video, please subscribe and share with your friends. Thank you.